going to review everything we talked about properties and more about the distributive property. So let's go over a lesson. A baking company charges $1.75 per slice of cake for baking. Then they charge another 35 cents per slice for decorating. So how much would a decorated cake cost containing 150 slices? Generate two equivalent expressions using the distributive property. So you could have done it this way. So I know there's 150 slices. If I bake it, it will cost $1.75. And then I have 150 slices. After I bake it, I'm going to have to decorate it another 35 cents. So I could have done it this way. Some people say, why don't you? Well, we know we're going to bake and decorate together. So why don't we add up those two first and then multiply by how many slices there are. And those are the two generate equivalent expression. Will you get the same results from this? Let's see. This is distributed. There's 150 groups of $1.75 plus 35 cents. So what's 150 groups of $1.75? Oh, right there. Plus 150 groups of 35 cents. It's right there. So give an example, again, of commutative property. So commutative property is back and forth. Is 4 plus 3 the same as 3 plus 4? It is the same. You just generate it. What about 7 times 2 is the same as saying 2 times 7? It is. Commutative property. Associative property is like associating with different numbers. Like associating with your friends. You have different amount of friends. Like 1 plus 4 plus 9 and you can solve it differently. Because some person may have solved it this way. I group the 1 and the 4 together, and that's 5. 5 plus 9 is 14. Another person will say, why don't you group the 4 and the 9 together and get 13 plus the 1 is 14. Did they generate equivalent expression? They did. They just did it differently. It's different methods, but it's still the same answer. Identity problem is where you get the exact same response. Same identity. Like you all have, when you got 16 or older, you're all going to have an identity card. And so an identity card is a picture of yourself. So 5 times 1 is 5. Same identity. 11 plus 0 is 11. Same identity. It didn't change. Inverse, the way I memorize, is like reverse. So you have reverse. You have 8. Oh, the little song. So you have 8. What's the reverse of 8? Negative 8. So it's 0. What about 7 times? What can I multiply by 7 to get the reversal of that? By the reciprocal. 1 7, you get 1. And last but not least, you have distributive property. You have 8 groups of x plus 4. So if you draw this, you can't draw it. You have an x and you have 4. Oh God, why did I choose 8 groups of it? I'm going to have to draw 8 groups of x plus 4. Why did I choose this? 1, 2, 3, 4, 5, 6, 7, 8. How many x's do you see here? I see 8 groups of x's. How many groups of 4s do you see here? I see 8 groups of 4. If you collect them, what's another way to say this? I have 8 x's. And how many 1s do you see? 32. That's how you generate equivalent expression. So what if you did not want to draw it like Mr. Joe? You got done this way. What's 8 groups of x's? Right there. And what's 8 groups of positive 4? Right there. It's 8x plus 32. So before we go, let's talk about factor puzzle. What do you know about factor puzzle? So in this one, in our next lesson, we're going to learn how to factor out things. So we have 2 and 10. What factor goes into 2 and 10? 2. And what are the factors of 2? 2 times 1. What are factors of 10? 2 times 5. Let's bring this down. What are the factors of 15? 5 and 3. And 3 goes here. So 1 and what do you get when you multiply 1 times 3? 3. And that is our factor puzzle. Let's try another example. We're just practicing with factoring out things. 35 and 45. What factor goes into 35 and 45? I believe a 5 goes into it. So what are the factors of 35? 5 and 7, or 7 and 5. Commutative property. You can say either one. What are the factors of 45? 5 and 9, or 9 and 5. So let's put 9. What are the factors of 27? 9 and 3. Let's go right here. What are the, and put 3, and what 7 times 3 is 21. Next one. And last but not least, what factor goes into 27 and 24? 3. What makes 27? 3 times 9, or 9 times 3. What makes 24? 3 times 8, or 8 times 3. All right, what factor goes into 24 and 40? 8 and 8 times 5. And then you have 9 and a 5, and this is 45. So you might say, why did we do this? We're just practicing our factors. Now, let's practice it without using that puzzle. Can you find the greatest common factor, or GCF, or the highest number that divides exactly into 2 or more numbers? What factor can you divide? What factor goes into 20 and 25? What can you divide 20 and 25 by? I can divide both numbers by 5. Anything else? No, that's the greatest. What about 63 and 81? I can divide both numbers by 9. What about 36 and 60? I can divide both numbers by 6. Wait, stop. Is there a greater number? What about 12? 36 divided by 12 is 3. 60 divided by 12 is 5. And last but not least, what is the greatest factor you can divide 24 and 40 by? Some of you will say 4, but it's actually 8. So taking what we learned here, now we are going to factor out each expression to generate an equivalent expression. 20 and 25. Is there another expression that you can rewrite 20 and 25 as? What can I divide both of these? What's the greatest factor that can go into 5? So, what makes 20? 5 times 4. What makes 25? 5 times 5. So, is 5 groups of 4 plus 5 the same as saying 20 plus 25? Is it? Let's see. 5 groups of 4 plus 5 groups of 5. It is. So what we did is factor out. It's funny. This is almost like, I can't believe, this is FOIL method. If any of you are, your parents are saying, oh, I remember FOIL. This is what I learned in algebra. This is an algebra. This is like an algebra lesson. It's like, what can you, you're factoring out. What is the greatest number that you can divide this expression by? So, what can I divide 20 and 25 by? Both numbers by 5. I divide both numbers by 5. And that's why I got 5 groups of 4. And what do I left? 5 groups of 5. Next one, 63 and 81. What is the greatest factor I can divide 63 and 81 by? By 9. So if I divide, so what makes 63? 9 groups of 7. And what makes 81? 9 groups of 9. Is there another way to write this? You could write it as 9 groups of 7 plus 9. Either one is acceptable. What about next one? 36 and 60. What can I divide both numbers by? I'm going to divide both numbers by 12. So what makes 36? 36 divided by 12 is 3. So it's 12 groups of 3. And 60 divided by 12 is 5. So it's 12 groups of 5x. So 12 groups of 3 is the same as saying 36. 12 groups of 5x is the same as 60x. Is there another one you can write? This is correct. Another way you can do it is, what about saying 12 groups of 3 plus 5x? So it's like using distributive property but doing it completely backward. It's like your reverse, instead of like doing arrow like this way, you're doing backward. And last but not least, 24x plus 40. What is the greatest factor I can divide that go into 24x and 40? 8. I can divide both of these numbers by 8. So if I divide this both numbers by 8, that's 8 groups of 3x, and 40 divided by 8 is, so it's be 5, 8 groups of 5. And is there another way to rewrite this? This is correct. If you write it this way, I'll give you, this is correct. There's nothing wrong with that. You can also rewrite it like this way. 8 groups of 3x plus 5. That's what's inside of parentheses. Because if you want to check your work, what's 8 groups of 3x? Right there. 8 groups of 5, right there. And that's it. So, so what we did here is we found another way to generate an equivalent expression by factoring things out. We divided, we found the greatest factor or greatest number that go into each term. And then we factor it out, and we are left with different groups. So this is just a extension more of distributive property.